Welcome back. This is Mrs. RRubright with Advanced Geometry. Today's lesson is on 10.1, using properties of tangents. Use properties of tangents. You should have already copied the vocabulary from page 641 and the for your notebooks on pages 643 and 644. Example 1. Identify special segments and lines. Tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. So this right here is a segment. It doesn't have any arrows, so this is really essentially just like a couple of endpoints. It's segment AC. So AC, this portion of a line, is a segment. So this is segment AC. So is it a radius, a chord, a diameter, a secant, or a tangent? This is a radius. It goes from the center of the circle to a point on the circle. It is a radius. Segment AB. Segment AB is not one, but two radii. It's a segment going through the center of a circle, touching two ends of the circle. Therefore, it is a diameter. And a diameter is a chord that contains the center. So a chord is a line segment that connects to two ends on the circle, two different points on a circle. So like right here, this is a chord. So a special type of chord that goes through the center as well is called the diameter. It is a chord that goes through the diameter. Ray DE. Ray DE. So it goes from D to E and has an arrow in one direction. This is intersecting the circle at one point. It is a tangent to the circle, so it always is perpendicular to the circle at the point of intersection. So ray DE is a tangent ray because it is contained in a line that intersects the circle at only one point. With arrows on both sides, that is a line. Line AE. So let's look at line AE. Line AE is right here. Line AE. This line cuts through the circle and intersects it at 2 points. Because it cuts through the circle, intersecting it at 2 points, this is it a radius? No, it doesn't go from the center to one side. It is not a chord because a chord is a segment. It is not the diameter because the diameter is a chord that contains the center of the circle. A secant or a tangent. A tangent intersects the circle at only 1 point, so this must be a secant. A secant is a line intersecting a circle at 2 points, and it continues through the circle. In example 1, what word best describes segment AG and segment CB? So segment AG is right here. Segment AG is a chord. It is a chord, not a diameter, because it does not go through the center. And because it's a segment, we know it's a chord. Segment CB is a radius. It goes from the center of the circle to a point on the circle. That is a radius. In example 1, name a tangent and a tangent segment. So a tangent and a tangent segment. So a tangent intersects the circle at 1 point and it always intersects perpendicularly. So we can call this tangent DB or tangent DE. So we can go with line DE, line DB, line BE, right? So as long as you're writing it as a line with two of those three letters, that would be a tangent. A tangent segment, instead of making it a line, you just make it a segment. DB or DE, just make it a segment, not a line. Use the diagram to give the following lengths. The radius of circle A. So the radius of circle A, from the center of the circle to a point on the circle. My radius here is 1, 2, 3 units. the diameter of circle A. If the radius is 3, then the other radii is also 3. The radii are both 3, therefore the entire diameter is 6. The radius of B, we have 2 units. Try the diameter of B. What do you guys think it is? It is 1, 2, 3, 4, twice the radius. It is 4 units. Use the diagram in example 2 to find the radius and diameter of circle C and circle D. The radius of circle C is, take a second to try this one out. Good. The radius of circle C is 1, 2, 3 units. The diameter of C, if the radius is 3, the diameter is twice that, it is 6. Now try the radius and diameter of circle D. You should have gotten that the radius of circle D is 1, 2 units, making the diameter 4 units, twice the radius. Tell how many common tangents the circles have and draw them. So a tangent that it intersects both circles at only one point. So you could have a line that goes kind of like that and another one that goes kind of like that. Over here we could have, oh, and then couldn't we also have one like this and one like this? There's 4 of them. Over here we would have 1, 2, 3 of them. And all of these are lines. I just have to add my little arrows to my tangent lines. And it's a common tangent because it's tangent to both circles with the same line. Tell how many common tangents this circle would have. Think about this one. Take a moment. Think about it. And then we'll go over it. If you need to pause the video, go ahead and pause. All right, so let's take a peek at this one. So we would have 1, 2. 2 common tangents. Tell how many common tangents the circles have and draw them. This is the same thing we just did. Once again, there are 2. On this one, think about this one. You should only have one common tangent. Are there any common tangents here? Right, there are no common tangents. In the diagram, segment PT is a radius of circle P. Is ST tangent to circle P? Well, if it's tangent, then this would be 90 degrees. But it has to be, if it's not tangent, then it's not 90. So let's check and see whether or not this is 90. We're going to use Pythagorean theorem. A squared plus B squared must equal C squared if this is 90 degrees. Let's see if that works. I have to grab my calculator. 35 squared plus 12 squared .37 squared is also 1369. They are equal, therefore this is a right angle, so yes, it is a tangent. Since the Pythagorean theorem works, it is 90 degrees, therefore it is tangent. In the diagram, B is a point of tangency. Find the radius R of circle C. Okay, so it says that this is 90 degrees. So since that's 90 degrees, then 80 squared plus R squared must equal 50 plus R. squared. So these would be together, because this is the entire hypotenuse is 50 plus r. 50 plus r squared is 50 plus r times 50 plus r, which when you FOIL that out, you get 2,500 plus 50r plus 50r plus r squared equals 80 squared, 8 times 8 is 64 with 2 zeros, plus r squared. Subtract r squared from both sides, and it's gone. So you have 100r plus 2,500 equals 6,400. 6,400 minus 2,500 is going to be 3,900. So you have 3,900 equals 100r. Divide by 100 on both sides. R is 39. RS is tangent to circle C at S, and RT is tangent to circle C at T. Find the value of x. Anytime that you have two tangents with a common endpoint, they will be equal. They must be equal. If they're both tangents to a common endpoint, it makes this kind of like birthday hat, they will always be equal. So set them equal and solve. 3x plus 4 equals 28. Subtract 4 from both sides. 3 times what equals 24. Divide by 3 on both sides, and x equals 8. Is DE tangent to circle C? Well, let's check this out. If it's tangent, then this must be 90 degrees. Let's check and see if it is. 3 squared plus 4 squared must equal, what is my hypotenuse? It's 2 out here, and if my radius is 3 here, then it's also 3 here. 3 plus 2 is 5, equals 5 squared. Some of you might have noticed that this is a 3, 4, 5 triangle, which is a special right triangle, and you don't even have to do this math. It will be a right angle, therefore it is tangent. 9 plus 16 equals 25. 25 equals 25. Yes, it does. Therefore, it's a right angle. Since it intersects at a right angle, it is a tangent. ST is tangent to circle Q. Find the value of R. So R, once again, 90 degrees. R squared plus 24 squared must equal R plus 18 squared. R plus 18 times R plus 18. When you FOIL it out, you get R squared plus 18R plus 18R is plus 36R plus 18 squared. And 18 squared is 324. And 24 squared is 576. Subtract R squared from both sides, it's gone. Subtract 324 from both sides, and you get 252 equals 36R. Divide by 36, and you get R is 7. Moving on to our last slide. Find the value of x. Okay, so let's look at this one. This, once again, two tangents intersecting at the same point, so they are equal. So x squared must equal 9, square root, x equals positive or negative 3. Can we have a negative length? No. Therefore, x must be 3. Although actually when you plug it in, you're going to get negative 3 squared is 9. So it actually will work. Positive and negative 3 both are solutions, because negative 3 squared is going to give you positive 9, and 3 squared is going to give you positive 9. So you actually do have both answers, and they're not extraneous. I hope you enjoyed our lesson on 10.1. Wow, this long lesson. Use properties of tangents. Subscribe to our channel and like the video for more YouTube videos by Mrs. RRubright. Thank you so much for listening, and have a wonderful day.